Welcome. This tutorial follows the procedure described in Appendix B of the online version of the Abacus Getting Started Guide. You can use Appendix B to follow along as the tutorial progresses. To begin, select the Abacus CAE program on your computer. If Abacus doesn't start automatically after a few seconds, type Abacus CAE into the command prompt window that appears. From the Start Session dialog box, click on Create Model Database. Abacus now enters the Part module. In the model tree on the far left of your screen, double-click on Parts, name your new part Beam, and enter an approximate size of 300. The model tree provides a visual description of the hierarchy of items in a model and is explained in detail in Appendix B. Next, sketch a rough rectangle using the Rectangle tool in the toolbar. Click the center mouse button, otherwise known as mouse button 2, anywhere in the viewport to exit the Rectangle tool. Use the Dimension tool to specify that the left edge of the rectangle should be 20 mm and the top edge should be 200 mm. When you have finished the rectangle, click mouse button 2 to exit the Dimension tool, then hit Done in the prompt area at the bottom of the screen. Since you selected an extruded part when you created this beam, the Edit Base Extrusion dialog box opens. Specify a depth of 25. Abacus CAE displays an isometric view of the beam. This is a good point to save your progress. The next step is to create a material and assign it to the beam. Double-click the Materials container in the model tree and name the new material Steel. In the Material Editors tab, click Mechanical, then Elasticity, then Elastic to assign the appropriate properties to the material. Assign a value of 209 times 10 to the third for the Young's modulus and 0.3 for the Poisson's ratio. Now double-click on the Sections container and create a solid homogeneous section called Beam Section. Click Continue and accept the created material Steel as the associated material. To assign the section of material to the beam, expand the Beam branch of the model tree by clicking the plus symbol next to Parts and then again next to Beam. Double-click Section Assignments and select the beam by clicking on it. Click Done in the prompt area, then accept the assignment Beam Section to the beam. Abacus now considers the beam to be made of your steel material. At this point, it is time to start assembling the model for analysis. Expand the assembly container in the model tree and double-click Instances. In the dialog box, select Beam and click OK. Next, define the analysis steps. Begin by double-clicking the Steps container and naming the step Beam Load. Select the Static General procedure. You will need an initial step to apply the boundary condition that will fix one end of the beam, and a general step where you apply the pressure load to the top of the beam. CAE generates the initial step automatically, but you must create the general step yourself here. In the description box, enter Load the top of the beam. Now explore the various tabs in the Edit Step dialog box. Take a moment to examine the field output requests and history output requests by right-clicking on each container in the model tree and selecting the Manager option. These functions allow you to select the region of the model Abacus will generate data for, the variables Abacus will output, the frequency at which Abacus will output data, and many other useful tools. Use the Edit section of the Manager window to view these options. then leave the default selected and exit the managers. The next step is to specify the boundary condition that is present in the initial step. To do this, double-click the BCs container in the model tree and name the new boundary condition Fixed. Select the initial step and accept the mechanical and symmetry settings. After clicking Continue, select the far left end of the beam. Hit Done in the prompt area and toggle on Incastra in the dialog box that appears. Because of this boundary condition, the left side of the beam will remain fixed during analysis. Now you can apply the load on top of the beam. Double-click Loads in the model tree and name the new load Pressure. Select Beam Load as the step in which the load is applied. Accept Mechanical in the category list, and choose Pressure in the Types for Selected step list. In the viewport, select the top of the beam as the surface where the load will be applied. Hit Done in the prompt area, then enter a magnitude of 0.5 for the load. Now right-click on Loads in the model tree and select the Manager option to ensure the beam load status says Created. The final step before starting the analysis is meshing the part. Start the process by expanding the Parts and Beams branches of the model tree, then double-clicking on the mesh container. Abaqus automatically switches to the Mesh module. From the main menu bar at the top of the screen, select Mesh and then Controls. Accept Hex and Structured as the default element shape and technique selections. Using the main menu bar again, select Mesh and then Element Type. Accept the standard linear and 3D stress defaults, but click Incompatible Modes in the Hex tab. Examine the Wedge and Tet tabs for future reference. Now you've selected the type of mesh you want to use, click Seed and then Part in the main menu bar. Enter an approximate global element size of 10 and click OK. This tells Abaqus how large the default element size of the mesh should be. Click Done in the prompt area and select Mesh and then Part. Click Yes in the prompt area and Abaqus meshes the beam. The model is now ready for analysis. To start the analysis process, double-click the Jobs container at the bottom of the model tree. Name the job Deform, and after clicking Continue, enter Cantilever Beam Tutorial in the description box and click OK. You can look through the other tabs of the Edit Job box for future reference. Expand the Jobs container, right-click on Deform, and choose Submit. The job says Submitted when the analysis input file is being generated, Running when Abaqus analyzes the model, and Completed when analysis is complete. When the status says Completed, right-click on Deform and select Results to enter the Visualization module. To see the deformed beam, simply go to Plot in the main menu bar and check Deformed Shape. Click the Auto Fit tool so the entire model is in the viewport. Now go under Plot to Contours and choose Undeformed Shape to view a contour plot of the stresses on the beam. You can change the variables displayed by the contour plot by going to Results in the main menu bar and then clicking on Field Output. Try examining this feature. There are numerous ways to view your results in the visualization module, but we will only discuss how to view the deformed post-analysis model and how to show the stresses on that model. This tutorial is now complete. You have gone through each step from creating the initial model to examining the results of your analysis. What you have done here is only a very small sampling of the capabilities of Abaqus CAE, but now you have the basic knowledge to begin using Abaqus to solve your engineering problems. If you want to try more Abaqus examples, additional tutorials are available on the Simulia website or within the Abaqus Getting Started Guide. Thank you, and we hope you enjoy using Abaqus.